Good day to everyone. So today I'm going to discuss about the spectrochemical method. It's just a continuation from the previous lecture. Okay, this lecture is basically just for your understanding. Okay, more about the spectrochemical method. Spectrometer or spectrophotometer, basically it's an instrument that will resolve the polychromatic radiation into different wavelengths. And the type of the instrument component is basically depends on the wavelength region. Okay, students, why spectrophotometer and not photometer? So there is a difference between these two. So spectrophotometer is using a grafting or prism to provide a narrow bands of the radiation, while photometer uses the filters for the same purposes. Okay, students, the advantages of the instruments. So basically, the spectrophotometer is more versatile and has the ability to obtain the entire spectra, while the photometer has the advantages such as simplicity, low cost, ruggedness. Okay, so okay, students. The diagram here basically shows the block diagram of spectrophotometer. So here, the block diagram of spectrophotometer can be divided into the sources, monochromator, sample, detector, readout. Okay, so the spectrophotometer basically resolves the polychromatic radiation into different wavelengths. So, students, there is a source here. Okay, we will call these as the continuum source. Okay, continuum radiation. So sumber radiasi berterusan. Okay, continuum radiation. Well, the monochromator is basically to select a narrow band of the wavelengths, while the detector is to convert the radiant energy to electrical energy. So these components are vary for UV visible and IR reagents. So for the UV visible reagent, we will use the continuum source. Well, for the AS atomic absorption spectrophotometer, we will use the line spectrum. So, class, these are the example of the dispersion of radiation by a prism monochromator. So, in the monochromator, basically, the higher the frequency of the radiation, so the greater the angle of the reflection at theta. So, thus, it should be noted that the angular dispersion, which is d theta over dv, does not vary linearly with v. So class, in many spectrometric instruments, the monochromator is based on the prism optic. Okay, it's particularly for the cheaper instruments, they use the prism optic. So now class, the figure here shows the spectral sources type. So here, this is the visible source. So the spectrum of the continuum source is much broader. Okay, it's very much broader than the line source. So here, class, the continuum source is is used for the UVBs, while the line source is used for the AAS. So now class, basically a monochromator consists of the lenses or mirrors. Basically the function of lenses or mirrors is to focus on the radiation. And apart from that, it consists of the entrance and exit slits. So basically it's to restrict the unwanted radiation and to control the spectral purity of the radiation which is emitted from the monochromator. And it also consists of the dispersing medium, which is to separate the wavelengths of the polychromator radiation from the source. Now let's move to the monochromator slit width. So basically class, for the qualitative analysis, it requires narrow slits so that any fine structure in the spectrum can be resolved. Well, quantitative analysis can be tolerated Rather, we can use the wide slit width, since the measurements are usually carried out at the maxima, where the slope of the spectrum is relatively about the constant. It's relatively constant. There are three types of dispersing elements, which is prism, optical filters, and diffraction gratings. So, students, this is the example of the dispersion of polychromatic light by the prism. So basically, the white light will pass through the prism. So the dispersion by the prism is good at short wavelength, and we can say it's poor at the long wavelengths. Okay, students, let's move to the optical filters. So as for the optical filters, for the UV range, we will use the quartz, which is the path length is 0.1 to 1 cm. Well, for the visible range, we will use the glass and the quartz. And for the near IR, the range which is between 800 to 1100 nanometer. So we will use the IR salt crystals. So the figure here shows the diffraction radiation from the grating. So basically the intensity here, it depends on the angle from which the radiation reflects. So now class, let's move to the type of spectrophotometer. So here we are going to discuss about the single beam spectrophotometer and double beam spectrophotometer. So single beam spectrophotometer, basically it has only one beam of the light. Okay, here we do not measure the incident radiant power, which is the P naught. Well, the radiant power of the light that passing through a reference cuvette containing a pure solvent is defined as the P naught. Then the cuvette is removed and replaced by an identical containing sample. So that is the single beam spectrophotometer. So how to differentiate between the single beam instrument and double beam instrument? So in single beam instrument, it's employed a fixed beam of radiation that irradiates first the solvent and then the analyte solution. While double beam instrument, the solvent and the solution are irradiated simultaneously. And in double beam spectrophotometer, the light is passed through the sample and reference cuvette by the rotating mirror. So that is what we will call as the beam chopper. So that's all for the spectrophotometer's second part. So thank you for your attention, class. Thank you.